Hello and welcome to TN Academy. For today's question, we are given a particle that moves in a straight line such that its velocity, v, is in meters per second at t seconds, which is given by v at t is equal to 4e to the power of negative t over 3 cos t over 2 minus pi over 4. And all of this is we are mapped out on the interval 0 to 4 pi. And the graph is actually shown below, of course. And we're given the statement that t1 is the first time when the particle's acceleration is 0. So that's its starting point. And now for our first question, question A, we're asked to find the value of t1. Okay, so to find the value of t1, we can use this given fact here, where t1 is the point at which the acceleration is 0. So to find t1, we must first find acceleration and equate it to 0. So we have to integrate, take the derivative of v at t, so v prime t. Now, because we have this equation here, we have a constant, we have a function with e in it, and we have a cos function. So what you should take from that is that we have two functions essentially, so we have to use the product law, where dx of fx multiplied by g at x is equal to fx times g prime x plus f prime x times gx. So it's either way you want to do it. It's the derivative of the first function multiplied by the second function, and then the plus the derivative of the second function multiplied by the first function. Now some more rules here. So that's one of the rules, and then we have to use the rule on for integrating a function of base e and to integrate a cos function. And the two rules after the product rule are for our function of base e and our cos function, where the derivative of a function e to the power of kx, where k is some constant, is the constant is brought in front of the function and the e remains the same, to the same power. And for a function cos of kx, where k is again some constant, our function becomes negative k sine of kx. Okay? So after we differentiate our function, it will become the following. So actually, after we find the derivative, after we differentiate our function, we will get the following here, where we've integrated our base e function, multiplied it by our cos function, and as you can see, I've done a little bit of simplification, kind of. I've removed a common term from the two, so that we can see when we integrate our cos function, it will the base e function remains the same, and it's multiplied by negative constant, our negative constant in the brackets, and the constant is 1 over 2 because it's 1 over 2t, and then it's multiplied by sine t over 2 minus pi over 2. Okay, and then we can then take out our like term of the base e from our function, and we can acknowledge the fact that since e to the power of negative t over 3 is always greater than 0, then it will not influence our roots. It's not the factor that we're looking for. Instead, we're looking for the cos function minus the sine function, what these terms do. And in what case that they make our function equal 0. So this is what we're focused on now to find our roots. So we can say that 0 is equal to negative 1 over 3 cos t over 2 minus pi over 4, and then minus 1 over 2 sine t over 2 minus pi over 2. And there is a trigonometric identity here that we should acknowledge, whereby, say this term is a, this constant is a, and this constant is b, then for these constants, let's say that then tan of a over b, tan, And then of this term, we will call it z. They are like terms, which we should also acknowledge. I've miswritten the second one. My apologies. Should be a pi over 4. Then tan of z will be equal to a cos z minus b sine z. So what we will do is use this, I was trying to use the red, use this identity to rewrite our equation so that we can evaluate for the roots. Okay, so when we do this, we then get the function 2 over 3 tan of t over 2 minus pi over 4 is equal to 0, and we can rearrange that so that we get tan t over 2 minus pi over 4 is equal to 3 over 2. Then we can take the inverse tan of our function so that we get t over 2 minus pi over 4 is equal to inverse tan of 3 over 2. And then we could continue to rearrange by subtracting or adding pi over 4 to both sides and then multiplying by 2 so that we find that t is equal to inverse tan of 3 over 2 plus pi over 4 all of which should be multiplied by 2. And then we plug this in our calculator to solve, and you will find that our answer is t is equal to 0.3948, which we can round to be 0.395 seconds. Okay, so that is our first question. Now for question B. We are asked to find the value of t2, right here, where t2 can be the second time our particle is instantaneously at rest, which would probably be somewhere around here. Now, to find the point that, t2, where first we know for B, it's this t2 is the second time our particle is instantaneously at rest. Particle is at rest. Yep. So we say that then we must recognize that V at t2 is equal to 0. So what we're essentially saying is that for our velocity equation, we can equate it to 0 and then evaluate for t. And now, if you remember our equation, which I will rewrite out, but again, we have our base e term and our cos term. And we know that since we're evaluating for the zeros, since our base e term for e negative t over 3 will always be greater than 0, then if we're evaluating for our roots, the only thing we have to look at is our cos our cos term. The only thing we have to evaluate is our cos term. So we can write out cos t over 2 minus pi over 4. Cos t over 2 minus pi over 4, and evaluate for when this is equal to 0 to find our roots. Okay? So doing that, we know that our function will only be 0 when t over 2 minus pi over 4 is an odd multiple of pi over 2. Therefore, we can create the statement that t over 2 minus pi over 4 must equate to this, okay? So Now, for the following equality, we can use this equality to solve for t. So we will rearrange it and then say t over 2, write it a little lower, t over 2 is equal to 2n plus 1 times pi over 2. And we will add pi over 4 to both sides. And we will then multiply both sides by 2 so that we get our final statement for t. So that we isolate for t rather. Okay, and we can rewrite this by distributing our value of 2 so that we get wait just a moment, so that we get the following. Okay, and we know that now that we have this statement, we know t is equal to 4n plus 2 times pi plus pi over 2. We are evaluating this for the interval where t is greater than or equal to 0 and less than or equal to 4 pi, and and we'll substitute, essentially. We're going to substitute t into this equality to further evaluate and find our new variable, which is an integer, n. Okay? So we will rewrite our equality so that we can say t, which is 4n plus 2 times pi plus pi over 2 must be less than, greater than or equal to 0 and less than or equal to pi over 4. Okay. Now, if we continue to rearrange our equality, first we will have to expand this pi into our brackets so that we get 0 on our left boundary. Is 4n pi plus 2 pi plus 2 pi plus pi over 2 must be less than or equal to 4 pi. Okay? And we can then see that our interval is actually -2. 4n pi, we collect our like terms, of course. So we get 5 pi over 2, which is less than or equal to 2 pi. My apologies. So -2 pi and 2 pi. So our new interval is between -2 pi and 2 pi, where t is equal to 4n pi plus 5 pi over 2. Now, we are going to factor out our terms of pi so that we can remove it from our equality entirely. When we factor out our pi from our equality here, at least from the middle, from t, get 4n plus 5 over 2 less than or equal to 2 pi. Then if we divide our entire equality by pi, we find that 4n plus 5 over 2 must be less than or equal to 2. Okay? And finally, if we first subtract 5 over 2, so subtract 5 over 2 from our equality and multiply, or rather divide our equality by divide by 4. By 4, we find that the final equality becomes -9 over 8, n less than or equal to -3 over 8. And since n is an integer, then we know that n must be equal to -1. And so, since we know that t is equal to 4n plus 2 times pi plus pi over 2, we can substitute -1 into the equation to find t2, which is equal to 4 times -1 plus 2 times pi plus pi over 2. And when we evaluate this, we will get 2 pi plus pi over 2 is equal to 5 pi over 2, which is just equal to 7.85 seconds. And that is the answer for part B of our question. Okay, now for our final question, question C. We're asked to find the distance traveled between T1 and T2. Okay, so that should roughly be the area under this curve. Okay, now to find the area under the curve or the distance traveled, what we have to do is integrate our function, which is so we have to integrate our function given in the initial question for the motion of the particle, 4e to the power of -t over 3 cos t over 2 minus pi over 4, and we have to integrate it over the interval t1 is equal to 0.395 seconds and t2 equal to 7.85 seconds. Okay, so now given that we have a function with both a base e and a cos, we will have to use integration by parts. And the rule for integration by parts states that for integral u dv, the integral must be found by evaluating uv minus the integral of v du. Okay? So we apply this formula first by we state that we're letting v be 4e cos theta, 4e negative t over 3 cos t over 2 minus pi over 4, and we will let u equal our cos function, cos t over 2 minus pi over 4. And then we must find both dv and du. So dv is then 4 okay, my apologies. I was actually getting ahead of myself. So this, we have to use integration by parts. And what it is that we do is we will be letting this be our dv. So that, I believe that was still correct. But anyhow, and we will let our cos function be u, be denoted by u, or represent the function u. So we say that u is equal to cos of t over 2 minus pi over 4. Okay, and that dv, well, you have to work backwards, but v, oh my gosh. For our final question C, where we're asked to find the distance traveled by the particle between T1 and T2, you can integrate
this equation and do so over evaluate the integral at t2 and t1. Although that's quite a lengthy process, which requires integration by parts and integrating twice so that you can actually, I will show you, so you can cancel out your variables. So I believe, anyhow, you do integration by parts, so you have your function integration by parts, where integration by parts is represented by this equation here. And essentially what happens is, after having integrated the entire function twice, it will be such that the integral of cos, your cos term, as well as your integral, can essentially be translated over, evaluate for the answer in turn. But an easier way is to find v1 and v2 for t1 and t2, and then since v is equal to distance over time, then distance is just equal to velocity times time. So then you could find the second distance and the first different distance and find the difference of the two. And so that's exactly what I did, and found that our answer for part C is 0.9 meters. Okay. The previous answer was 0.16. But if we round it up, our answer would be, I don't know, I guess pretty close. So yeah, anyway, that is the answer to question C.